Okay, we're trying to make this number an integer. An integer is a whole number, positive or negative. This one, of course, will be positive, but we're dealing with little bitty numbers. So what we want to do is use a form of scientific notation. So 1.25 is 125 times 10 to the negative 2. I'll move that decimal 2 places to the right. And the next one is 5 times 10 to the negative 3. And then this one would be 25 times 10 to the negative 5, because we had to move it one. Oops, I don't want to use an eraser here. We had to move it 1, 2, 3, 4, 5 places. And then we have this 10 to the r. And we're trying to figure out what r is. Well, what do we have here? I've got a 125 and a 5 and a 25, but I recognize I can write all those as 5s. That's a 5 cubed times 10 to the negative 2, and then a 5 times 10 to the negative 3, and then a 5 squared times 10 to the negative 5. Then I've got that 10 to the r. So how many 5s do I have? 3, 4, 5, 6. So 5 to the 6 times 10 to the what? Negative 2, negative 5, another negative 5, it's negative 10 times 10 to the r. Now, we want this to be an integer. When you multiply by 10 to the negative 10, that moves your decimal 10 places to the left where you have a point and a bunch of zeros, a decimal and zeros to the right. So we need to get rid of this. 5 to the 6 is an integer already. Okay, it's a whole number. So what we want to do is counteract that negative 10, and we're going to do that by letting r equals 10. 11 would work, 12 would work, but the problem says the smallest value of r. Yes, smallest value of r. Because you know, if you have 10 to the negative 10 times 10 to the 10, when you multiply like bases, you add your exponents, and that gives you 10 to the 0, and 10 to the 0 is 1. So your answer was 10.